Welcome to your next set of notes. Before we get started, I want to show you if you fail, never give up, because fail means first attempt in learning. End is not the end. In fact, end means effort never dies. If you get no as an answer, remember no means next opportunity. So maintain your positive thinking. Now moving on to today's notes, we're going to talk more with multi-step equations, and this time we're going to see that variables are on both sides. Same as before, these are your keys to success when solving the equations. Your first step is always to distribute, and then combine like terms when they are on the same side of the equal sign. Then your next step, this is new, you're going to get all the variables on one side of the equal sign and then all your constants on the other. And then we will make sure that we maintain these inverse operations to get our variable by itself. Lastly, check our solution. So our first example, we have the variable terms on both sides of the equal sign. And that's what we're always going to start with. We're always going to start with the variable terms. And what I suggest, and you'll see I always do this, is I take a look at my variable terms and I always start with and work with the one that is the smaller number. All that does is it reduces my the times that I have to work with the negative numbers, and so it does reduce my mistakes. So I have 8x and negative 7x. So I'm going to go ahead and add 7x to both sides. I'm choosing to work with the 7x because the negative 7x is the smaller of the two. Now we add them up going left to right. So 2 plus 15x is equal to 32. Now we're at that two-step equation, and we're going to go ahead and get our constants to one side. So we'll go ahead and subtract 2 from each side. From here I get 15x is equal to 30. Divide each side by 15. When I do that, 15x divided by 15, I'm left with x. 30 divided by 15 is 2. Moving on to number 2. The first thing I see parentheses, so I need to make sure I distribute. So I'm going to go ahead and recopy everything except what I distribute. So 3 times 1 is 3. 3 times negative x is negative 3x, equal to x minus 17. My next step is to combine like terms on the same side of the equal sign. So I have a 3x and a negative 3x. That's where I'm going to combine. And when I do, I get 0. So I'm just left with 3 on the left side, and then I'm going to recopy everything else. Okay, so nothing wrong here. My goal is to get x by itself. I'm almost there. So inverse operations will move the constants to the other side. So I add 17 to both sides. 3 plus 17 is 20. Drop down everything else. I have 20 is equal to x. I can leave my answer like that, or I can recopy it as x equals 20. Either way is acceptable. Problem number 3. Again, let's make sure that we distribute first. When I distribute, I get negative 12x minus 8 is equal to 18x minus 18. I'm always going to check to see if I can combine like terms on the same side of the equal sign. So nothing to combine on the right, nothing to combine on the left. So when there's nothing to combine, then I'm going to start moving all the variable terms to one side. I look at the smaller of the two. Negative 12x is smaller, so I'm going to do the opposite. I'm going to add 12x. If we do it to one side, we do it to the other. Remember, that's your property of equality. Then we add them up left to right. Okay. From here, I'm going to go ahead and get my constants to the other side, so I'm going to have to add 18 to both sides. Negative 8 plus 18 is 10, is equal to 30x. And I kind of seem to have run out of room here. To solve for x, I'm going to divide both sides by 30. When I do that, remember that rule of dividing when your numbers end in 0? You can just cancel those out. So I have x is equal to 1/3. I'm going to let you guys know right now, so hopefully you are paying attention, otherwise you will get these marked wrong. that we aren't going to leave our answers as a repeating decimal, okay? Write them as a fraction. Repeating decimals would be incorrect unless I tell you otherwise. All right, number five, we're going to have to distribute. We're going to have to combine like terms, a lot that we have to do here. I'll do this next time I see you in class. You are more than welcome to try it on your own and see if you can get the same right answer when we check it together. Let's go ahead and talk about special cases, numbers of solutions. So there's something called a null set.
The following room should have left for pictures 115, 116, 118, and 119.
So I'm getting interrupted by announcements. The null set is when one value equals a completely different value. We would write down no solution. One solution, this is the stuff that we've been working with, where your variable equals a number. I have C example 3. C example 3 is one example that you could use that we just went over. And then we have the identity property or identity solution. We write it as infinitely many solutions. It's where the same value equals itself, and it's actually going to be example number 5. So let's change that to number 5. And this one will actually be example number 6. So let's work these out so you know exactly what this means. So for number 5, we're going to start with distributing. When we distribute, we have 6x minus 18 plus 10 is equal to 6x minus 8. We're going to combine like terms on the same side of the equal sign. And so what I'm going to combine is negative 18 plus 10 and recopy everything else. Then we start with our variable terms. So I'm going to go ahead and subtract 6x from both sides. 6x minus 6x is 0, so I'm going to drop down 8. 6x minus 6x is 0, and I'm drop down that negative 8. They are the same value. So just like right up here where it equals itself, that reflexive property. So this is when we use reflexive property, and we're going to go ahead and write down our answers, actually infinitely many solutions. So that is what we are going to write down. Infinitely many solutions. Okay, now let's go ahead and try number 6. Number 6, same thing. We want to make sure that we distribute first. When I distribute, I get 32 minus 16x is equal to 12 minus 20x, drop down plus 4. Then we want to combine like terms, if necessary, on the same side of the equal sign. And so on the right, I'm going to make sure I do that. And then we recopy everything else. From here, we start with our variable terms. So I'm going to go ahead and add 16x to both sides. So I have 32 is equal to 12. Does 32 equal 12? No, it does not. So when we come back and we talk about this null set, where one value is equal to a completely different value, okay, that is called no solution, null set. But we'll just write down no solution. Okay, that's it for the front. Let's flip it over and do a few story problems together. So let's go ahead and start with number 7. Number 7, we're going to write and solve an equation. Make sure only algebraic solutions will be accepted. So what I mean by that is you need to make sure that you are writing an equation. The other thing that you need to make sure you're doing is labeling your variable and writing a sentence to answer the question. So we have 9 times the quantity of a number plus 4 is 8 more than 5 times the number. What is the number? So we're looking for what the number is. So x is going to equal the number or number. Now my equation, 9 times the quantity. Quantity does mean parentheses. So it's going to be 9 parentheses. A number plus 4. So a number, well, that is what x is. So x plus 4 is 8 more than, so I'm going to end that quantity. Is my equal signs. 8 more than 5 times the number, 5x. Okay, I have my equation. I can go ahead and solve. So let's go ahead and do that right now. We'll start with distributing. So I get 9x plus 36 is equal to 8 plus 5x. Now let's get all of our variable terms to the same side. So I'm going to go ahead and subtract 5x from both sides. Again, that's because the 5x is the smaller of the two terms. 9x minus 5x is 4x. Drop down everything else. Now all of my constants to the same side. So I'm going to subtract 36 from both sides. I now have 4x is equal to negative 28. Now I'm going to divide both sides by 4. And so I find that x is equal to negative 7. So negative 28 divided by 4 is negative 7. We're going to write a sentence to answer this. The sentence is simple. The number is negative 7. There we go. Our next one, let's go ahead. We'll do this next time I see you in class. We'll do that one together, okay? Let's jump to number 9. Number 9, the square with side length x plus 3 and an equilateral triangle with side length 3x minus 1 have the same perimeter. What is the value of x? So what I'm going to do is I'm going to go ahead. There's not really a way to label our variable this time, so I'm going to draw a diagram. I'm going to draw a square that have equal side lengths, and each side length is x plus 3. I could label that all 4 around if I wanted to. Next, we have an equilateral triangle. Remember, our equilateral triangle has equal side lengths, and each one is 3x minus 1. Okay, now it is saying that they have the same perimeter. Remember, perimeter means to add it all up. So for my square, it's going to be 4 times x plus 3. Or I could add up and write out x plus 3 4 times. Okay, they have the same perimeter, so I'm going to write in that my equals. An equilateral triangle have 3 sides, all 3x minus 1. So that is the equation for this problem. Okay, let's go ahead and distribute and solve. So when I distribute, I get 4x plus 12 equal to 9x minus 3. Let's get all of our variable terms on the same side. Okay, again, I'm going to start with the smaller variable term, which is the 4x. I'm going to subtract that. Now think about this. Remember, I say it reduces our chance of working with negatives. So by subtracting 4x, I now have a positive 5x on that side. Okay, and this way I'm not working with a negative 5x. Then we'll go ahead and add 3 to both sides. When I do, I'm going to write this up top where I have a little bit more room. 15 is equal to 5x. Divide each side by 5, and I have 3 equals x. So the value of x is 3. That's my sentence. Okay, the value of x is 3. Okay, and then we'll do number 10 together the next time I see you in class. Okay, that's it for these notes. I will see you next time.